So here we're going to take a look at some more linear equations, but this time it's not going to be x plus or minus some number on the left-hand side. It's going to be a number plus or minus, well, it's going to be a number minus x or minus 2x perhaps later on, or some other coefficient in front of the x, right, which complicates things a little bit. So we're going to look at two different ways you can go about solving these linear equations when you're subtracting the variable, right? We have a minus x, right? Minus x here, right? A number minus x. So our first option is going to be just add or subtract the number that's not attached to the variable that's on that same side, just like we've kind of done in the past. So the number that's on the same side as the x that's not attached to it is a 12. And it's a positive 12, right? We always look in front to see if there's a sign, not after. Like that minus goes towards the x, not towards the 12. So it's a positive 12. So to get rid of a positive 12, we would need to subtract 12. Okay? So I'll do the same on the other side of the equal sign. Well, 12 minus 12 right here should cancel out. It doesn't affect anything after the 12. That minus sign and that x still stay. So we have negative x equals 5 minus 12. Well, 5 minus 12 is negative 7. And from here, we're just going to multiply or divide both sides by negative 1 to cancel out the negative side. And it doesn't really matter if you do multiplication or division. I'll write multiplication here. Okay? If I multiply by negative 1, negative times negative x, a negative 1 times a negative x should be a positive x. And negative 7 times negative 1 should give you positive 7. We end up with x equals 7, which makes sense because if I were to go and plug x equals 7 back into my original, I'd have 12 minus 7 equals 5. Well, that's true. 12 minus 7 does equal 5. Our other option, we're going to call this option 2, is to just add that variable to both sides. So I can add x to both sides. Now this might be a little confusing if you're not real comfortable with combining like terms yet, but I've got a video for that you can watch if you need to. But a minus x and a plus x should cancel each other out. Those are going to go away. So all that's left on the left-hand side is just 12. And on the right-hand side, because 5 is a constant and x is a variable, right, they're not like terms. They can't be combined together. So you just end up with 5 plus x. Or you could write it as x plus 5. It doesn't really matter. And now this is like one of our one-step addition-subtraction equations. The thing that's not attached to the x over here is a positive 5, so we'll subtract 5 from both sides. 12 minus 5 is 7, and 5 minus 5 cancels out. We just end up with a positive x over here. And we can see that regardless of which method we choose to use, we're going to get the same answer because there's only one solution to every linear equation. Right? Linear equations can only have one solution. They might have, there's only one solution to a linear equation. Right? So let's take a look here. 3 minus x equals 10. And it doesn't really matter which option you use to solve it. Either one is perfectly acceptable. We'll just do them both. So we could subtract the 3. So I'll rewrite this. 3 minus x equals 10. We could subtract the 3 from both sides. That would give us negative x equals positive 7. And this time we'll divide by negative 1. It doesn't matter. You could multiply by negative 1. But we'll divide. A negative x divided by a negative 1 is just x. And 7 divided by negative 1 is negative 7. And if we'd chosen to do it the other method, where we'll take 3 minus x equals 10, and write it again, where we add x to both sides, we'd end up with 3 equals 10 plus x, because we can't combine the 10 and the x together, right? Because one's a constant and one's a variable. Then we would just subtract 7. Not 7, subtract 10. I was looking at the answer already. We'll subtract 10 from both sides because the 10 is what's not attached to the x and on the same side as it. And 3 minus 10 is negative 7. And 10 minus 10 cancels out, giving us just x equals negative 7. So again, regardless of which method you choose to use, you're going to get the same answer. All right, here we've got negative 7 minus x equals negative 12. And we're going to go through and we'll do both methods again. This one's slightly different because we started off with a negative 7. Right? We'll write that over here. Negative 7 minus x equals negative 12. Now, to clear off a negative 7, we would need to add 7 to both sides. Right? The opposite of a negative 7 is a positive 7. So we'll add 7 to both sides. The negative 7 and the plus 7 here should cancel out, leaving us with negative x. And negative 12 plus 7 is negative 5. So now we just either multiply or divide by a negative 1. We'll multiply this time. Why not? Giving us positive x equals positive 5, right? X equals 5. And if we'd chosen to do this using our other method, negative 7 minus x equals negative 12, we would add x to both sides. Giving us negative 7 equals negative 12 plus x. And now on the right-hand side of our equal sign, we have a negative 12 that we need to get rid of. Well, to clear off a negative 12, we'll just add 12 to both sides. Negative 7 plus 12 is a positive 5. These ones cancel out here. And we're just left with 5 equals x, or x equals 5. Same as we got using the other method. And again, does not matter which one you choose to use. You'll always get the same answer. So now, we're going to have a different coefficient on our variable. Instead of it just being minus x, we'll throw something else in there, like minus 5x or minus 2x. Our same two methods are still going to apply. So we'll do this one using both methods again. So we'll start over here on the left with 3 minus 5x equals negative 22. And so our first step should be to subtract 3 from both sides, because the 3 is what's not attached to the x, but still on the same side. That leaves us with negative 5x equals negative 25, because negative 22 minus 3 more gives you minus 25. Now with the other problems, we were just dividing by or multiplying by a negative 1. But now this looks like our basic one-step equations, right? Where we have just a coefficient in front of the x, and we just need to divide by that, because that's the opposite operation of the multiplication between the negative 5 and the x, right? Remember, there's a multiplication, an invisible multiplication going on there between the negative 5 and the x. So to clear that multiplication, we'll just divide by negative 5. And we end up with positive x equals, and 25 divided by 5 is 5. And since they're both negative numbers, we don't want to write negative 5. We'll just say 5. Right? A negative divided by a negative gives you a positive. Now, when we do the other method here, we're actually going to end up with a third step. But that's okay. It doesn't really matter. Whichever way you prefer, whichever way makes the most sense to you to do the problem is going to be the best way for you to do the problem. So we'll do the same thing. We'll get rid of the minus 5x from the left-hand side by adding 5x to both sides. On the left-hand side, we're just left with the 3. But on the right-hand side, we have a negative 22 and a positive 5x. Well, since one's a constant, negative 22, and the other one is a variable expression, 5x, they cannot be combined together. So we'll just write them separately, negative 22 plus 5x. Now our next step, our second step, is to clear off anything that's attached to that same side as the x, but not actually attached to the x, right? The 5x is one thing. we've got a minus 22 over here that's not really attached to it. So we'll get rid of that minus 22. To clear off a negative 22, we're going to want to add 22 to both sides. 3 plus 22 is 25. And on the right-hand side, we have 5x. And again, we're now just down to a one-step linear equation where we'll divide both sides by the coefficient. We'll divide by 5, giving us 5 equals x. And we can see it's exactly the same as the answer we got using the other method. So we'll do 2 more here. We'll just do one method for each of them. I think for this first one, let's go ahead and use our first method. We'll clear off the negative 2 that's on the same side as the variable, but not attached to it. So we'll add 2 to both sides. And as an exercise on your own, you might want to try and do the other method just to make sure you understand. But here, we'll end up with negative 6x equals 42. Now it's a one-step linear equation where we'll divide by the coefficient, giving us x equals, well, 42 divided by 6 is 7. And since we have a positive over a negative, it'll be a negative 7 as our final answer. And if you want to go through and do it using the other method, right, where you would add 6x first, right, you should still get negative 7 as your answer. So give that a try and see if it works out for you. All right, for our last one here, we'll use the second method, which means we're going to get rid of that minus 2x first by adding 2x to both sides. On the left, we'll just have negative 3. And on the right, we'll have negative 11 plus 2x. Again, negative 11 is a constant and 2x is a variable expression, so they can't be combined together. And one thing to note, when we were first doing two-step equations, the x always came first. Okay? And we can rewrite this if we want to. Now, we don't have to. And I'm going to write it off to the side, but I'm not actually going to do the problem with it switched around. Since it's a positive 2x, I could write it as 2x first. And since it's a negative 11, I could write it minus 11 after. Right? So 2x minus 11 is exactly the same as negative 11 plus 2x. So these are interchangeable. You could write it whichever way you want to. I'm going to leave it how we had it, right, with negative 11 plus 2x, and eliminate the negative 11 by just adding 11 to both sides. Negative 3 plus 11 should be 8, right? If you have negative $3, and then somehow you get $11, well, now you've got 8. If you owed me 3, somebody gives you 11, once you pay me those 3 back, you're left with 8. And we have 8 equals 2x, and now we just divide by the coefficient of 2, giving us 4 equals x, or x equals 4. And that's how we're going to deal with subtracting a variable expression within our linear equations. And so 2 different methods. Use whichever one makes the most sense to you. Neither of them are inherently any better than the other.